My name is Mina. I'm the president of UBC Design League. Your workshop host is Jay. Jay, do you want to introduce yourself?
Hey, I'm Jay. I'm the VP of Technical at UBC Design League.
And what year are you in and stuff
No,
like that?
Sure. I'm in third year, chemical engineering. Done CAD for many, many years. And yeah, I mean, that's all I got.
And you're in a bunch of design teams as well, which is pretty cool. Like you're very involved overall in school, so.
Yeah, UBC Baja, UBC Design League, obviously, UBC Thunderbots, and Sigma Phi Delta, or my affiliations, I guess.
Yeah. So just a little bit of info about who we are. We're a new club in UBC. And basically we do a lot of events that could be workshops, competitions, or design-a-thons. We also have an architecture aspect to us. I will be providing you with this PDF if you're interested in getting involved with us or being in the loop for future events. We're going to have more CAD workshops, design workshops, idea pitching, architecture workshops, and all sorts of stuff. We're also going to host 2 design-a-thons in term 2, January or February. And design-a-thons are basically like hackathons that are for coding, but they're mostly for CADing. So if you're more of a visual person, if you're just like going to improve your CAD skills over time and you actually want to compete in a team, you'll have 36 hours in person to work on a design challenge that's like related to an actual company's work. And those people, like the people from the company, are going to be there as well. So that will give you a connection with them. And if you have a winning design, you can definitely have a chat with them. There's also going to be huge prizes for that one, like 3D printers. And we're also going to have an architecture design-a-thon. So look out for that. And yeah, we also have this thing called Design Lords. So if you join any of our competitions, this is a workshop, but when we do host competitions, if you join any of those, you will become a Design Lord, and we will also send you a mini prize. So if that's something that you're interested in as well, you can check us out. Yeah, it is 7:05 now. So do you want to start, Jay?
Sure.
Okay, awesome. I'll stop my screen sharing. Also, this is being recorded and we will provide the recording in the end. And one more thing, this is an engaging, how do you say? It's a workshop that's supposed to be engaging. So if you have any questions at any time, just put them in the chat. Jay and I will try to answer you, and just, ask people, like, be active in the chat. Don't feel like this is just a lecture. It's supposed to be engaging for you. So let's do it.
Yeah, I mean, if you guys have questions, you missed a step or whatever, just unmute and ask the question. I don't mind. It's good to know when people are falling behind. So, cool. I'll start my screen share. All right, I guess this is where we would start. Welcome. This is going to be a CAD tutorial, starting from the absolute basics and working up to like simple assemblies, simple drawings, and kind of give you like a general overall view of how you can CAD. I assume most of you are UBC engineering students going into first year or just coming out of first year. And I mean, you guys can type in the chat if that's the case or not the case. I'm curious where you guys are from. But yeah, this should be enough to get you past all the CAD you need to do in first year and then some. So going into first year, okay, yeah. So that's the demographic. Beautiful. So first of all, I mean, pretty sure in the descriptions it said get SolidWorks installed so you can follow along. I have it installed here. I'm just gonna get going straight from there. If you don't have it, no problem. The recording will be up and you can follow along there. Alrighty. Well, here you have SolidWorks. It might give you a nice little welcome message. It might not. It doesn't really matter. Let's just start off with a new file. So you're going to click this button here. You're going to click Part and hit OK. And with some loading, you should get your part file. The way this program works, essentially, oh yeah. So the way this program works is essentially it's all about making a reference and then making something three-dimensional with that reference. And there's lots of functions that can do lots of things, but generally, to begin with, we're going to start out with a flat plane of reference, and we're going to essentially pull a shape out of that. You can imagine like a cylinder is a circle that's being pulled upwards. You can imagine a cube as a square that has been pulled upwards, and whatever. It's essentially just a prism. And the way we're going to make that prism is by clicking Sketch here. I'm going to click Sketch to start a sketch here. And by the way, if you forget what any of these buttons do, you can just hover over the button, tell you exactly what it does. It's pretty helpful. Click Sketch. And what we have here are your reference points. Program doesn't really know where you want to start this two-dimensional reference, right? So it gives you the three options around the origin. Use the XY, YZ, XZ planes, essentially. Let's just go with top for now. What we're in right now is called a sketch. This is your two-dimensional reference, your cross-section of what you want to make, essentially. So if we want to make, like, let's say a cylinder, right? You can click, these are your sketch tools. So this is how you draw what you want. You click circle here, start it, the center, and just pull it outwards at whatever radius you want. No worries if you don't get it the first time, you can always just change it here, change the locations here. And yeah, let's go with 50 here, 50 millimeters of radius. All right, sorry, for context. I'm using middle click to rotate around something. Shift middle click to zoom. And control middle click to pan. To repeat that if you're following along, that's middle click to rotate, shift middle click to zoom, and control middle click to pan. All right, so this is what we have. We have a circle on a plane. And the way we turn that into something three-dimensional is we're going to exit our sketch here. So it tells the program, okay, I'm done working with this two-dimensional surface. I'm going to go to our features over here, and these are your essentially the button set that lets you convert your references into something three-dimensional, right? So you're going to click Extruded Boss and Base. So essentially what that lets you do is take a closed reference, a closed profile of something, and pull it out until it makes something three-dimensional. And I guess the theme of this tutorial would be to make a guitar. So if you imagine a guitar bass, well, I'll get to it. We'll make the guitar bass. But if you imagine the guitar bass, you're essentially drawing the shape that you want, which can be any shape, you know, doesn't really matter. And you're going to pull that out to a certain thickness. But we'll get to that. For now, you can click Extruded Boss Base. And if it doesn't automatically select your plane, just click on it. It's no big deal. And this is essentially you're pulling out of your plane here. You take a look at this, tell you how far you're pulling it out. You say I want it exactly 100. I can pull it back down. I can pull it into the negatives if I want it to go downwards instead of upwards. And there's lots more options here that you can choose if I wanted to go both directions. Don't worry about thin feature for now. You can also set different preferences. So instead of saying I want it to be 10 thick, I can say I want it to go up to a certain thing, up to a different reference. And that's helpful if you don't exactly know how far you're going. Because, this is all about not doing the math. So I'm going to click blind, going to click some distance, doesn't particularly matter what. Let's go with, I don't know, let's say 50 again. Fun thing about SolidWorks, just a quick aside, it doesn't matter what units you're using. You can use literally anything and it'll just take it. Here, 1 inch automatically converts it. 1 foot. I wonder if this works. 1 kilometer. Nope. Okay. Anything within this reasonable set. Yeah, okay, let's go with 50 for now. And there you go. Your first simple part. I'm just using middle click to rotate around it now. And that's how you make a part. Pretty easy. On the left here, you can see this is called your Parts Explorer or Feature Manager in SolidWorks or whatever your program of choice likes to call it. But essentially, these are all your features in your part file. So you can look at the material here. I'm gonna skim over that for now. We'll get back to that. We have the front plane, the top plane, and the right plane, which is the reference planes we were working with earlier. If you want to see these planes, you just right click and click show. It's right there. And this is the part we just made. You can just click on this and click edit, go into it and click, I don't know, 100 here. And it'll just do that for you. And you might be wondering, why didn't it double its height? So the program hasn't gone through and recalculated all the parameters you've given it. So you can just click rebuild here. So it's this red green light on top, and it'll essentially recalculate all your parameters for you. If you want to edit the profile that you made initially, you can click this button right here, and it'll give you the sketch. And let's say you want to work on the sketch again. You want to edit the diameter of this. Just right click that, edit sketch, and now you're inside the sketch again. You can exit the sketch. I can change this diameter to something else. You can change the shape entirely, doesn't really matter. Once you're done, just click exit sketch on the top left. Cool. I'm going to pause for a second. People have questions. I want to hear if I'm going too fast, too slow. I'm not a prof, so I don't have a timeline. I will wait you out. Edit the sketch, sure. You have a sketch right here on the left. I'm going to click that, and you're just going to click this edit sketch right here. Or if you don't want that, you can just right click this, and you have a set of options. So the top left one is going to click edit sketch, and you can change it from there. Which part of the cylinder? The essential idea is you just take the sketch. Let's get rid of this and make it again. You have a sketch, a two-dimensional reference plane. And you can just go into it, draw a circle, which is over here. Click exit sketch, click extruded boss phase, which essentially just pulls it out. Like that. Click what you want to pull out. Give it a distance, select it here, and click check mark. Hopefully that was sufficient. Any more questions before we move on? Get to top plane view. Okay. You can control middle click. Oh, sorry, just middle click to rotate around. But if you want exactly specific views, you can press your spacebar, and the program just lets you choose the view side you want. So let's say I want top. I click that. Back to the top. And keep going from there. If you really want to look head on at your sketch, you can just hit spacebar and then what you want to look at. Also look at planes. Click here. But yeah, that's how you get back to the top plane view. Spacebar, click top. Scroll wheel zooms out when I scroll up, and oh yeah, I have the same. There's an option to edit that if that's not your preference. Go to settings up here. Somewhere here. Lots of buttons. It's somewhere in here. Play maybe. Anyway, somewhere in these options here. Look for it and maybe scroll. Nope, those don't look like the options. It's something you can edit, yeah. How to edit the radius once it is a cylinder. Okay, if you click this little drop down here, it'll let you look at the sketch again. You click the sketch, you edit your sketch, and click the circle, and it'll let you change the circle. And you can like type in an exact value here if you want, of course. But yeah, that's how you make the cylinder and edit afterwards. And then once you're done, you just click exit sketch. That work for you, Balga?
I got full. I couldn't eat.
Sorry, what's up? Cool. Let's get going then. Lots more buttons to get through, and then we'll show you the more complicated stuff, and then we'll get on to the guitar part. All right, let's start off with a clean slate. Just gonna right click, delete, yes, and then delete this as well. All right, so I'm looking back at my blank slate again. I got my 3 planes. And I guess now is a good time to talk about how exactly this program will work. When you're looking at a part in your head or in like a physical part that you have, you can think about the symmetries of what you're trying to make, and it'll make your job a lot easier. So let's say you have something on hand that demonstrates this. Here's the lid. You know, you can look at it, and you can look at what types of symmetry this lid would have, right? You can think about an axis that goes straight through the center of this, and that axis is rotationally symmetric with this. I can also put a plane through here, and it's symmetrical this way. And what that lets me do is it lets me make more complicated parts without having to remodel over and over and over again. That lets you essentially constrain things within the patterns that you see in something. And you'll get used to this, but there's lots and lots of different ways to pattern something. And we'll get onto that. So let's start with a different way to model a cylinder. Trust me, it'll be worth it. We're going to click sketch again. We can go on the right plane this time. And now we're just going to go with the rectangle select. Click one of the corners and click another corner. Doesn't really matter. this is essentially, if you can think about a cross section of a cylinder cut in half. It's kind of weird to think about, but we'll get there. We're gonna finish up the sketch. So we're gonna close that, exit sketch, and then we'll have this little rectangle in our plane. Now, the magical part. If you click Revolve Boss Base here, what this button means is I'm taking something and I'm revolving it around an axis, and I'm making something three-dimensional out of that revolution. So the path it would trace when going around this axis. We go to Revolve Boss Base, and I think it already has it selected. If not, it should give you the option. And now it's asking for an axis of revolution. And I'm just going to choose this. So if you can imagine, if I pin this onto this axis and I pull this around in a circle, the path it would trace is your cylinder. Just hit OK there, and there's my cylinder. And that comes from the idea of your rotational symmetry. You can take something relatively simple and rotate it around, and it'll make a significantly more complicated looking part. And just to kind of demonstrate what that is, you don't have to follow along for this one. Kind of demonstrate what other rotational symmetries there are in things. I'm going to be making a sketch. Again, don't follow along. I'm going to go fast. Putting the line up and a line there. Going to spline. Might be able to kind of see what I'm getting at here. Features, revolve. Now, if somebody wants to talk into the chat what I'm trying to make here, if you can see what this rotational symmetry will let me make. Nailed it. There you go. Easy. There you go. That's your base. You know, let's say this one's a bit too far out, and I kind of don't like that width there. Just edit sketch, pull that point in. It's kind of like sculpting. Rebuild, and there's the base. Then let's say, you know, you want to put things in this phase, right? Because most phases aren't just, you know, solid hunks of circle. The way you're going to do that, here, let me just start from the beginning so you guys can follow along. Just start with the box. Oops. I'm going to go into sketch. Sketch here. I have to choose my top line. I'm going to click my center rectangle because I just want this to be centered. All these buttons here are essentially the different ways you can draw things. And you can go through all these buttons on your own time. If you're really confused about what something does, lock this to my screen. If you're really confused about what something does, hover over it and it'll tell you. I'll give you a little animation if you're not sharing your screen like I am. So the way we're going to do that is we're going to click the center here, go outwards, and just click outwards. And it'll give you a rectangle centered on the circle. And just a different way to draw it. You can click other ways. It doesn't really matter. And click check mark. And let's say you want this to be a cube, right? And instead of doing math, because we don't like math here, right? We're engineers, we don't do math. We're just going to go into this button right here. Click add relation. Going to click, oh, sorry, let me escape first so it doesn't select everything. Add relation. Click that line look like that line. I'm going to say that they're equal. And now it's a square. I don't like that. Check mark. And it'll let you, adjust this in a perfect square manner. So you just told it, I want this to be equal, and you do the math for me. Okay, let's exit that sketch. So we have this, and how would I make this into a cube to make this more interactive? Watching the Twitch chat below. Extrude, hell yeah. Extruded Boss base here. Click what you want to extrude. And just pull it upwards. Nice and easy. Hey, okay, now we have a box here with unknown sides. It doesn't really matter for this. This is for this example. And we're going to make this into a box that can actually contain something. And the way we do that is this button called shell. Essentially takes whatever part you have and it'll just put a shell around it and make that the part instead. And kind of demonstrate how it works. It'll just immediately hollow out the interior of the part. If I hit check mark here, it'll be a hollow part with this thickness. But if I click specific faces, like the top here, it'll ignore that face. To kind of demonstrate how that would work for multiple selections, I'm going to undo that, Control Z. Click multiple faces, and there we go. Nice and easy. Cool. Yeah, there you go. That's how you make a box. And you can kind of like extrapolate on how this would work for a, okay, sure. So I have a cube. The shell button right here, it's under the features tab. It'll immediately make a shell of what you're doing. So I guess you can't see the inside of this, or your view button, right? If I hit check mark, it'll literally carve out the inside. But if we want to, like here, I'm going to undo this. If we want to ignore a face on this, like let's say this top face right here, and we hit check mark, it'll give us a hollowed out thing with an opening on one end, essentially. Which makes stuff like faces really, really easy. Let's make one just for demonstration's sake. Again, don't really have to follow along on this one. Then just showing you what the feature can do with an example. If you want to draw things and you don't really know any curves that would fit it, you can kind of just eyeball it if you're not making something technical using the spline button right here. Kind of just lets you put different points on your plane and it will just interpolate between them. That's a pretty terrible base, but that's fine. Hit escape to cancel the point, and then just connect the bottoms. And kind of graze it out so you know it's a full profile. The check mark, sketch, have to revolve it because that's how we make our base. And I can tell it to make it a shell, and I want the top to be open. I want the thickness to be much thinner, say 2 millimeters. There we go. Fully hollow. Now this is just to demonstrate what it looks like on the inside. Yeah. There you go. That's the coverage of both the revolved boss base function and the shell function. Cool. All right, let's move on to, let's go with Swift. The thing about the extruded boss base function is that it only allows you to pull it up in one direction, perfectly normal to the plane that you're working in. Let's say you want to go like that way, or like curve it along a path like a pipe would, right? Or those chemical engineers do tend to make from time to time. So to make this pipe, we just start out on the top line. We're just going to give it a circle. Radius doesn't really matter, and hit check mark. So we have a circle, right? And we're going to exit sketch. But we don't really know how to make this. I'm not sure why this still exists. Oh, it's this. Okay. So when we click the extrude button, right? The only thing we can do right now is really just pull it upwards. But we can't really push it from side to side and make it go along the curved path, right? So the way we're going to do that is by going into sketches again. And I guess if your planes aren't visible, right? You can essentially just make them visible and then click your start sketch function, or you can just start it directly on an invisible plane. We're going to click sketch and do the options. This is a bit hard to see because I messed around with my SolidWorks colors, but you can just select your planes if you just click this drop down menu here. I'm going to choose something that's not the plane we're working on because we want it to curve to a different plane essentially. And the way we're going to do that is going to click, like, let's say, front plane. And now we're on this front plane. And if we click right click and click normal too, we'll be looking straight at the plane. And that'll make it really easy for us to sketch. So let's say I'm a really creative chemical engineer, right? I don't do things by the rules. I don't make pipes straight. And machinists hate it, but that's beside the point. I'm going to choose Spline for my pipes because I want to make this thing super hard to model. I'm just gonna kind of just throw it in places, and there we go. Okay, escape. And this is kind of the path I just want this pipe to follow. Let's bring it upwards initially. And I guess the application of this would be, you're 3D printing a part and you have manufacturing methods that can handle this kind of thing. But anyway, you have your circle, then you have a path you want it to follow. So just going to click exit sketch there. And these are two separate sketches, right? This one right here is your circle, and you can rename it and you keep track, essentially document what you're doing. So let's right click, rename tree item. I'll tell you exactly what you're looking at. So now we're going to go into features. We'll click the Swift boss face. This is essentially the button that lets us take something and pull it along a path of our choosing. So what this says right here is a profile. You can just hover over things and it tells you what they are. But first it's asking for the profile. This is essentially the shape that we want to pull along this path. And then it asks me for the path. Pretty simple. So we're going to click the path, and it's essentially just going to pull it along the path that we want. And the way it's going to calculate that is if my path goes this way, it'll take the circle and it'll tilt the circle as it goes along. But it could be, that's not something you want, right? You can say keep normal constant, and it'll essentially just flatten it as it goes along. So instead of turning it along the path, it'll just follow the path with a flat line. But for a pipe, we want the curvature to follow the path. Check there. And there we go. Here's our pipe. 10 points to anybody who can tell me how we hollow this pipe out. See, it's interaction. Shell, yes. In fact, not cell, yes, shell. Like the shell button here. Say I want this side to be open, this side to be open, and just a check mark. There we go. There's a pipe that follows our path. We look on the inside of this pipe. This is just section view. It's nothing you have to really worry about. I'm just doing it for demonstration's sake. But yeah, that's this pipe cut in half. You know, it's a perfectly functional pipe, and your machinist hates you now. Cool. That's finishing off the swept boss base function. So far we've gone through extruded, the revolve, the swept boss base. Now we're going to move on to lofted. I'm just gonna wipe everything I've done. Cool. Let's say, you know, all the things we've done so far has been a uniform shape that we kind of like pulled along a path, right? We haven't changed this shape at all. But what if you want to, right? Let's say you have a drill bit. That's a pretty practical application of this. And you have a drill on one end, which takes a square bit, and you have something on the other end that's a heart. You know, you have heart-shaped screws. How would you make this drill bit? And the way we do that is essentially through the Lofted Boss base function. What it does is essentially it interpolates your shape between a shape you give it and another shape you give it. And we'll kind of demonstrate how that works. I'm going to go back into Sketch and click Sketch here. I'm going to click the top plane because I want it to go upwards. And, you know, just give it a square. And the way we make this a square is just click this. Sorry, click Escape, and then this. Add relation, the top and the side. I want them to be equal. Now let's say, you know, I want this to be a certain size because I'm making a drill bit, right? This needs to be defined to the size of my drill. And let's say it's 1 centimeter. The way we're going to do that is we're going to click Smart Dimension. Click on the thing that we want to dimension. And by the way, for some reference, blue means that you can change it. Black means that you can't. Black means that you've already given it something that says you can change it. What that means for this shape is I can't change the diagonals because they're already defined by these sides being equal. But let's choose one of these sides. You can place this wherever you think it's best visible. It's kind of just asking you, you know, where do you want to put this so it makes the most sense to you? And for me, that means right here. Just click there. I'm going to say 10 millimeters or 1 centimeter. And I'll handle that. The check mark. And then we're going to exit the sketch here. So now we have one side, right? But we don't have a way to tell it to start drawing at a higher point, right? Like I only have these 3 planes. And I need to make more, right? Because I'm not really sure how I'm going to draw all the way up here. And the way we do that is by using this thing called reference geometry. So these are your references, right? If you're working on a more complicated part, you literally just make all of your references beforehand and then work with your reference geometry to kind of like CAD from the outside in. That's important for some things like Baja's suspension geometry, for example. But for this case, you know, we can say that I want this drill bit to be 3 centimeters high. Any number doesn't really matter. I'm saying 3 centimeters high. The way we're going to do that is going to click on Features, Reference Geometry, with Plane. And I'm going to give it a plane to work off of, right? And this is a terrible first reference, so I'm just going to delete that. This is saying start at the origin. What I want this to be, I want this to be parallel to the top plane, right? Because we want our part to be flat all the way throughout. I'm going to click top as our first reference, and it'll give us a message that is fully defined as of now. Because what I've given it is I've given it a plane to work off of, and I've given it an offset, which it kind of automatically did here. If I don't want this offset, you can do other things, like I can make this perpendicular, and then it would require another reference, for example. I can choose parallel, which it already was. I can choose a specific angle if I want this to curve. I can choose a distance, which I'm going to do. And you can select midplane if you want it to be between two separate planes. You can also select multiple references. So let's say you want a plane defined by 3 points. You just select your 3 points as your 3 references, and it'll let you make a plane from there. But what we have here is our top reference, and then we're going to give it an offset distance, right? And we want this to be offset upwards, so we don't flip it, right? You have the option to push it downwards. We want this upwards, a distance of 3 centimeters, all the way up there. And then we're just going to hit check mark. So what we had here was we had our top plane. And what we did was we just gave it another reference to work with, this one here. And this isn't a 3D part. It won't print out a piece of paper if you 3D print this. It's just some reference to work on. And then we're going to go to the top. And the way we're going to do that is going to click our sketch. And instead of clicking sketch on the top plane, we're going to go to the new plane we just made. Right there. And now we can see that we're kind of drawing upwards from the surface. I'm just going to look exactly at what I'm drawing. Zoom in. And there we go. Now let's say, we're making a heart, right? And a heart has symmetry. And I mentioned this earlier. And the way we make parts is essentially through the symmetry. So what kind of symmetry do you guys see in a heart? Yeah, the vertical symmetry, right? So the way we're going to tell the program that we want this vertical symmetry is just make a line, and we're gonna make this line vertical. That's all. It's literally all. Give it a vertical line, easy. And then we're going to try and kind of draw a heart around this. And I'm just gonna kind of eyeball this. Doesn't particularly matter where I go from, but I just need to stay on, let's say, one of the sides of this line. I'm going to do the right, but you can do the left just as easily. I want to go upwards from here. Let's stop about there. Hit escape to cancel the next line. And I want this to be a curve, right? So I'm going to choose an arc because I think that's the best way to do this, but you can choose a circle and just fix the circles to the ends and then cut off the bottom part of the circle. Or you can do multitudes of other things. But I'm going to use the arc function here. I'm going to click the tangent arc and say I want it between this endpoint. So click that and that. Pretty easy. Check mark. Escape. And I'm going to kind of resize this heart into what I think actually looks like a heart. And you can see that this is kind of kicking outwards a bit. And the way you would fix that is essentially just say, I want this line to be tangent to the circle. And the way we tell the program our constraints for this design is just by telling it that it is a constraint, right? Look here, click here, add relation. This to be tangent to this. It tells me tangent. Cannot convert it into a line or an arc in the sketch plan. Okay, cool. There we go. Handled it anyway. But now this is tangent. We'll click check mark. And now I can move this outwards or inwards, and it'll stay tangent to what I've done. We're just going to make sure this is still only on this side. And now we're going to work on the other side of this one. And the symmetries you guys mentioned earlier, the vertical symmetry, we can think of as kind of a mirror, right? You can take a mirror on this side. I guess you can't see my screen like that. We can take a mirror and put it along this plane, and it's going to look like what you want on the other side. And the way we mirror it over this line is by clicking mirror. Entities to mirror, so I'm going to choose this, with the mirror about this plane. There we go. There's our heart. Easy, easy. Cool. Now that's all we need from this plane. Going to exit sketch. And there we go. Something we have. Not a fan of this line. Let's go back into the sketch just to make sure we don't get future errors. Now this is already selected as your outer line, but if you're only going to use a line for your construction purposes, you can just tell it it's for construction. You know, if you click on the line, like for construction, check mark, it won't use it to make your outline. And kind of demonstrates that by becoming a long dash, short dash line. Mirror button, sorry. Mirror button is up here. It says mirror entities in your sketch. So you're going to be inside your sketch. So you've already selected this and click the sketch, or if you haven't left the sketch. And on the very top, it says mirror entities. Yeah. Got it, Michael? Cool. Righty, just gonna exit the sketch here. And then we have our two planes and a shape. Not there enough. But there we have a plane here and a plane here. And these are kind of annoying. I like my workspace clean, you know? All I'm going to do is right click, and I'm going to say, I don't want to see this anymore. Click this. I also don't want to see this anymore. Little hide button here. And there you go. You have two profiles. And now you want to connect them, right? And there's no, the extrude button won't work, because if I extrude this heart down to the square, you get a heart at the bottom, not a square, and vice versa, right? So the button that does that for us is called Lofted Boss face. So we click top profile, and then we're going to click the bottom profile. And it does its wizardry. I'm not quite sure what it's doing here. It does its wizardry. And there you go. You have a square that fades into a heart. I'm not quite sure how this works. There's some complicated math behind this, but it'll do the work for you. And we don't do math here, so I have a square that goes into a heart. Let's say you have a heart-shaped drill bit, your heart-shaped screw head, and your drill bit on this side. And there you go. Nice and easy. Cool. Well, that's your heart-shaped drill bit tutorial. Let's get on to something a bit more complicated. I'm going to wipe this again. We delete the reference plane we made as well. And go back to our blank slate. There are three references here. Can't really see them. Let's make them visible. There we go. 3 planes here. Cool. Now all we've done so far is taken things and added them to things, right? It's all been addition. We've all taken like a circle and added the dimension to it. It's all adding material, right? If you're machining this is all going to be, you know, making more of it, with the exception of shell, obviously. You can't just shell everything, right? Sometimes you need screw holes and things. Sometimes you need a square hole and something. The way we're going to do that is by using these extruded cut functions. So you can think of these as kind of the negatives of your functions here. Now I'm going to skip over boundary boss because I don't think it's particularly useful. But all these buttons over here, your extruded boss, your revolve boss, your swept, and your lofted, all have their respective cut functions. And that lets you make some pretty interesting stuff. Honestly, if you stopped right there, that could get you through most of CAD. But let's keep going. Going to start just a quick cube. You know, you guys have done it already. I'm going to just add dimensions to it. So I want this to be 10 millimeters. I want this to be, already defined that one. Use this one, 10 millimeters. That's it. And then it's going to extrude 10 millimeters. I'm going fast, but you guys should know how to do this by now. Or hopefully you guys should know how to do this by now, if I'm doing my job well. But yeah, we have a cube now. And let's say we want to cut a hole through this cube, right? We want to cut a hole through the top of this cube to the bottom. I'm going to click Extruded Cut. That's going to ask me in a plane to work with, or a previous sketch that we can use to do this cut. And I'm kind of skipping the sketch button here. I just told it, you know, I'm going to make a cut with whatever I draw. I said that first. So we're going to click this top plane because that's where we're going to be cutting from. And then just draw a circle up here. Whatever radius, let's just say 3.5. And click Exit Sketch. So we're done with that. Now program is like, yeah, okay, you already told me that you want to cut through this part. And it's going to do exactly that, right? It's going to say, I'm cutting through this part for a distance of 10 millimeters. Well, let's say I don't want to do math, right? It's all about not doing math as many times as you can. So let's say I really don't want to calculate what this distance is, right? I can just say, you know, screw it, just go past it. That doesn't matter because it's cutting through nothing, right? And that makes the exact same part. Or I can be extra lazy and say up to a surface and click the bottom surface. That's all the way through. Or I can say through literally everything. Also works. Cut extrudes. Here, let me jump back then. Features. So you have all your buttons here, and your extruded cut is just on this top or right beside it. So these are your positive functions. These are your negative functions. So yeah, I use extruded cut for this hole because it's only going in a singular direction. I don't need to revolve it. I don't need to turn it from a square into a heart. I don't need to make a pipe out of it. It's just a cut. And I can go through all of these, but you guys get the idea of what's going on now between these functions and these functions. If you use different CAD programs like Inventor, some of them just have an option literally inside the extruded boss base function to choose between extrude and cut. SolidWorks like to separate them for some reason, and it works the exact same. Hole wizard. Let's say you want it to have a thread. Click thread, and I assume sometimes your files work. So you can just click a thread, click what you want the thread to be on, and it'll handle that. It's a lot easier than working with a corkscrew. Cool. It's nice and easy. But now I have this block with a 7 millimeter diameter hole through it. That's 10 millimeters cubed. Yes. Let's say I want this to, I want this exact same block, and I want like 5 of them, just all glued together. And we can see that symmetry in it, right? We can see that I can take an object and I can copy it a bunch of times, because I like copying and pasting for everything that isn't my essays, as far as you know. So the way we're going to do that is we're going to take this linear pattern here, and it's just telling it, I want it to be a pattern in this direction, right? You can give it a direction, and I want it to pattern upwards this way, up and to the left. So I'm going to choose a line that goes up to the left, which is this line right here. And I'm going to click features and faces, because it's asking what I want to copy. Let's say I want you to copy all of this, literally all of this. Just give it all. And then it's going to ask me, what direction do you want this? I want it to go up and to the left. So I'm going to just flip it until it goes that way. You can also choose up to a certain reference, but we're going to go with space for now. And the way it determines this is it'll tell you what the distance is between your parts, and it'll tell you how many instances you want. I said 5 earlier, so we're just going to give it 5. Easy, super easy. So just to recap, I clicked the linear pattern button. I selected the features and faces I wanted to copy. I selected a direction, which was this top left edge here. And I told that I want 5 copies, each 10 millimeters away from each other. Oop. Check mark. And then we go. Easy. Now let's say I wanted it to be like kind of a square, right? I want, just a grid of holes on my surface. And the way we're going to do that, if we go back into the pattern, like edit feature, I'm going to say I want a second direction, direction 2. I want to go this way. That's going to select it for me. I'm going to say I want 5 instances this way as well. Oh, the direction. There we go. So I select 5 instances this way, 5 instances this way, and it kind of compounds them for you, and it creates this. Lots of symmetries. It saves you a lot of work. So I'm just gonna turn off my lights. Cool. All right, there we go. We have a set of holes in a block. It seems kind of uninteresting. So let's move on to presumably what you guys all came here for, which is the guitar design. So we're going to wipe this once again. And we're going to choose, say, a reference image to make this guitar off, right? And we don't like to do math here. We don't like to look at something and think, what dimension is that? Kind of just eyeball it usually, right? And the way we do that essentially is by taking an image and just tracing it. That's the least work. We're lazy. So we're going to do that. It's going to click, sketch here. for reference for the people watching this on the recording or the people who are zoned out, this is when the guitar design is going to start. We've got the top, and we're going to essentially just draw the basic shape of our guitar. Now, I kind of just Googled guitar sizes because I'm lazy, and it gave me this image. But also, I think this guitar looks kind of lame, and given the freedom that we're working with, I think we can do something better. So I Googled another image. I thought this was a cooler body to work from, so we're going to be working off of this body. So we're going to make this exact part that you see here. And, you know, you're all creative people. I'm sure you can design your own guitars. All you have to do is just follow the general steps that I've gone through here. But yeah, this is our body image. I'm going to say I want an image, and let's see if I remember where the image button is. Insert. Hopefully it's here. Somewhere in one of these masses. Okay, I'm going to find this function and get back to you in a second. I think this is important for you guys to know. It'll be really easy to go with. Oh, finally, there we go. Okay, so where we insert an image into a sketch specifically is through tools, sketch tools, sketch picture. It's an awful place to put it if you ask me, but so click that and kind of just tell it, you know, this is where my part is. So I'm just going to go into my files, select the body, and just toss it into the program. I don't really want it to be this way, right? Here, let's. This is the, okay, so we kind of want to put this in a place where it's easy to work with. And the easiest way to work with this for me is putting this kind of parallel to the top line, right? We want our guitar to be designed upwards. So I'm just going to rotate this in a way that it fits the top side. And to scale it so it fits, you know, whatever the size of an actual guitar is, and go from there. So I'm just going to toss the picture in. And like exit sketch. Essentially, our image is right here. It's in our sketch, and we can work from there. So you can work in the same sketch that the image is in, or you can make a new one and just keep it visible as you design. I wouldn't say one is particularly good practice over the other. It's kind of just up to your preference, but we'll go from there. Sizing is kind of unimportant for now, but you can scale it using the scale tool here. You can rotate it using, you know, say 45. A bit more. 55. There we go. And just center it right there. And click check mark. And there we go. We have our sketch image here. I'm just going to start on a new sketch because I feel like I shouldn't be poking around in this image. So we'll go here, select the same plane we used, It's the top plane. And now we're working a separate sketch on the same plane. It's the exact same surface. We're just keeping our files separate, essentially. And now, it's tracing time. Lazy. And the way we're going to trace this is by going to spline function or the style spline function, and making a shape for a guitar. I'm going to leave you guys 5 minutes or so to do this. Choose a shape for your own guitar. Choose something that looks fun to you. But I'm just going to trace this image. If you find an image online, toss your own image in. If you kind of just want to freehand it, feel free to do that as well. That is somewhat tedious, yeah, but this is the fun design part. Something to think about while you draw your splines. Only click as far as it still stays fit. So if I do if I keep going this far, it stops being a good fit. Or I guess this one doesn't, but if I click let's say here, and I choose this, it'll start pushing this side outwards, right? So just select it as far as it fits, and then choose the next point for the next line. It's kind of just stitching them together. Cool. I have my outline. I'm just going to cap it off with a straight line, just so say closed profile. And that is all for now. I'm gonna wait for a few minutes so you guys can, design your own guitars, make something cool. Maybe show me if you're really feeling like it. Cool. Okay, let's move on. So now you've got this closed surface here, or presumably closed. We'll move on to what happens when you can't close it. But exit sketch. Sketch here. I'm going to hide the guitar sketch. If you kept it in the same sketch, just click down there, right click, and you can hide the image itself. Excuse me. And you should have, your closed surface of guitars. If you don't, edit it until you do. And now we're going to extrude this, right? So extruded, right part that we want, and pull it upwards. And now I'm going to ask the chat how thick an electric guitar is supposed to be. So I never really thought about it. Otherwise, I'm going to Google it. 1.75 inches, beautiful. Okay. 1.75 inches. That looks about right. And there you have your guitar body. Super easy, right? And if you think about what the rest of the guitar looks like, you have an extrusion here, or maybe a loft if you wanted to have that kind of curved surface on the bottom. And then the fretboard is, I think that's, yeah, the fretboard is just going to be your flat extrusion upwards. And the warning part at the end, the word is slipping my mind, is also going to be just extrusion, right? You just tell a surface you want it to be at. If you look at this image right here, you'll have, some angle here. But if you look very closely at it, it is just an extrusion this way, right? It's a flat, unchanging image that just goes a bit that way. And you might be wondering, hey, Jay, if I machine this, aren't I going to cut my hands? The answer is yes, because you didn't tell the machinist, or you didn't tell the machine, or you didn't tell whoever's making this how curved you want this, right? So this edge is going to be sharp, like extremely sharp. And if you don't tell them anything, they just won't break that edge. Like, this will cut your hand if you ask a machinist to make this. And the way we avoid that is by adding things like a fillet or a chamfer. So this button right here, right beside the linear button we used earlier, let's choose fillet or chamfer. What this does is it either adds a curved surface or a flat edge to whatever you're making, right? So I'm going to use both of these functions just to kind of demonstrate what's going on. I'm going to choose chamfer and say I want this edge and this edge. And I've chosen too large of a distance, and I know it's too large of a distance because it isn't showing me what's going on, which means it's just impossible to do. If I click yes here, it'll just fail. But let's collect like 2 millimeters or something. 2 millimeters. There we go. It's kind of just cut off that edge and soften it to some degree, right? But we want this to be an angle. How about that? That's pretty fun, right? So instead of 45 degrees, let's give it like 20. Like, I don't know. 1 millimeter maybe. Okay, it's going that way. So let's choose. So this 20 degrees has been chosen to be 20 degrees this way on this side and downwards on this side. And that's not what we want. So we can essentially just do this one side at a time to kind of make it a symmetric part, or we can just mirror the entire thing. But for now, let's just keep it at 45. So we're going to go to chamfer, both our edges, 45, and let's give it like 4 millimeters. Maybe that looks pretty nice. Maybe a bit more, say 5 or 6, maybe. Yeah, there we go. What it does is kind of smooth out my shape for me. Those of you with the more creative brains in this call will have made a part that fails if you try a chamfer too large. And that's normal. It's kind of just the constraints of reality at that point. You can't chamfer so hard you cut into other chamfers, essentially. For the most part. Sometimes it works, but for the most part, it won't work. And that's kind of just something you have to live with or find an alternative way to do. You can essentially do a path cut, a swept cut that you did earlier for the pipe, or you can try and extrude a larger shape of the exact same shape you made using your lofted cut, et cetera, et cetera. You have tons of options. What that means is just the function you want to do with the chamfer tool cannot be done with the chamfer tool. That's kind of just the unfortunate reality of CAD. It's just mathematically extremely hard to do, and there's multiple solutions. That kind of just makes it pretty jank. But yeah, skimming over that unfortunate reality, we're going to go with fillet this time. So it does is essentially the same thing as a chamfer, but it'll just round it for you. So I'm going to click all 4 of these edges I just made. I'll rise my computer because this is very, very heavy on your computer. Let's choose, say, 2 millimeters. Maybe that'll work. Yeah, okay. And this is essentially the radius of your curvature that you want on this part. So check mark. There we go. That's a very aesthetic looking curved part. And in real life, you wouldn't have these, let's just say a document. Do remember to save as you go along. I've kind of just been ignoring it for now because it's a tutorial. But this program loves to crash, and it loves to crash exactly when you're about to finish your part. It loves to crash exactly when you haven't saved your part in the last 3 hours. Also, one of the unfortunate realities of CAD. So please save. One of you might have already come across this. There's definitely a bug and not a feature. But yeah, okay, so we have a body, right? And it's time to add half an hour. Okay. So I'm just kind of show you how to decorate this to some degree, and the rest is going to be through your own abilities, hopefully. If you have questions, you can DM. But it's essentially just going to be an extrude from this side. You can go with a Lofted Boss base and kind of just think about what the cross section of the guitar would look like. And then the end would also be an extruded process. So I'm going to show you how to make this look nice, because you made something, you're proud of it, spent some time on your design. Let's make it look good, right? We're going to go on top here. Going to click shaded instead of shaded with edges, which is on for default. Go shaded. It'll look more realistic, right? Look at that. With the light shining on it, it's nice and curved. But it's still this gray blob of indeterminate material, right? And the way we turn this into some material is just by giving it a material. And to edit material, gave me tons and tons of options, right? And what wood was this made from? Anybody know what wood this is, approximately? I don't exactly know my woods. I'll pick something random if there's no response. Cedar, okay. Hopefully cedar's an option. Cedar, cool. That works. So we're just gonna click, whatever we want. Actually, you know what? Carbon fiber, let's make it cool. Carbon fiber guitar for the sake of CAD. Let's click apply after selecting our material. We're close. And there we have our body. I hope so. It's only imaginary, so you can make it as expensive as you want. If you want to actually, make this into a 3-dimensional part, your options are learning the SolidWorks routing here. If you go into SolidWorks add-ins and click on top, it'll let you essentially export this part into a path for your routing machine to follow. So that would be your CNC, your wood router, anything along those lines. And it's just something you can hand to your machinist and say, hey, I want this made out of, steel. And you're going to tell them what steel you want. You're going to tell them, what kind of CNC machine you want. You're going to pay them a bunch of money. And in the mail, what you'll get is exactly what you designed, assuming you didn't mess it up. That's the beauty of this, right? It's taking the idea from your head and turning it into something real. You can do this with wood as well. If you defined all of your sizes properly, You've looked at what the actual guitar size would be. You've looked at what fits your neck, your fretboard, your actual parts that you have on hand. This will work 10 times out of 10. But yeah, let's make this look fancier. It's still kind of, pretty flat, pretty grayscale. I choose a more obnoxious material, kind of stress what I'm with material. So with pure gold, beautiful. Now we have a pure gold guitar. And all of this is now fully set into the program, right? So you can look at this part and you can learn a lot about it. You can look at, where the center of gravity is, what the weight of this part is, et cetera, and it will give you all of this information. You just have to go find it in the respective function. But yeah, okay, so we have something here and we want to render it, right? We want to make it look good. And I don't know what options you guys have on this. If you have a Quadro card, SolidWorks will have these options. If you have an NVIDIA card, you can force SolidWorks to have these options. And you can just look up, force GTX on RealView. Let me type that into chat. Now, if you have an AMD card, I don't know. But yeah, we have a bunch of options here for your view. And an option here as well for integrated preview. I'm going to turn on RTX on, exactly. There is a ray trace button somewhere. But what I've told my computer to do is now render this. And render this, in the same frame that I set it to. I can move it around a bit if I really want to fry my computer. Can this model be exported? Exported to what? Okay. Export it as an image. Do you want to export it as an STL file, et cetera, et cetera? Turn this off. STL, gotcha. Okay. So presumably you've already saved this part, right? You can go to File here. We're going to go Save As. And in your options, there's going to be, let me pull it over. Can't find the render tools button. Yeah, that's the fix that I sent earlier. Sometimes GTX cards don't allow it. And it's kind of the sad reality of SolidWorks. It's often used as a professional program. Professional programs use Quadro. I don't like it, and I fixed it. I mean, yeah, it's RTX, right? It's not a Quadro card. It's faster than most Quadro cards, to be fair, but it's not a Quadro card. So I looked it up earlier. I sent a message earlier, Force GTX RealView on SolidWorks. Just follow that on the first YouTube video that comes up, and it'll be fine. Sorry, let's get back to the STL. So if you have your file here, you have the name, and you can select a file type that you want to save this as. I'm going to save as an STL, right? And if you click this option setting, it gives you a lot more info on how you're going to save it. You need to go, honestly, just choose these settings. These are your ideal settings. So save it as the largest file possible. If you change this tolerance, you can see that the inside of this, you can barely see that the inside of this is going to become blockier. It becomes a hexagon at that point at 30 degrees. And this tolerance is going to be the outside. You can set it to fine, or you can set it to custom and really crank it if you want. And this will make a very high quality version of what you want to do. Right. So let's say, you've got this and click OK, and then you just save it. And it's saved as an STL. Or once it saves, it's saved as an STL. Oh, it's a large file. I'm going to click no, but that's how you do it. Oh, yeah, so there you got your body. For those cutouts that the body had for your external parts, you can just make this this initial sketch visible. Once again, we're going to make this a wireframe so I can see what's going on. To kind of see the outside of it. And you can start essentially sketching on top using the Extruded Cut button and cutting into your part as you see fit. And you can export that as an STL, and then you have your guitar. That simple.